Hello friends. So today I am going to discuss about the CDK code that we will use to generate our VPC, virtual private cloud. So generally wherever if we search in any tutorial over YouTube, then we generally find that people are creating VPC or subnets by using the Amazon AWS console login, but in real time on in real world you will not create by doing the console login, and over the AWS console you will not do like that. You will have to write the ISC code, that infrastructure as a code, and there are several ways of writing the infrastructure as a code. You can use the stackers, you can use CDK. So here I am going to use CDK, and through CDK I will write the infrastructure code, and through that we will create the VPC. And basically CDK code we can write by using Python or by using the TypeScript. So here I am going to use the Python, and before that I am just giving a brief information about this AWS page where you can go through to get more idea about the CDK. And here it is having the detailed information about each functionalities that are being provided by the CDK. We can go through it and we can understand more. So you guys can go through it. And before creating our CDK application and before doing all the codings, let's understand what I'm basically going to do. So I have just created one small image here, and I'm going to describe this image, and this image only we will going to replicate in our code. So first of all, what is VPC? So I'm expecting here that we already know what is VPC. VPC is basically virtual private cloud. So why it is virtual? Because we are not getting any physical network, any physical hardware. It is all on the cloud, AWS cloud, and on cloud there will be a virtual network that will be private for our account. Okay. And all the EC2 instances, whatever, or all the other services that we are creating under this VPC can communicate internally without going to the external network, like external internet. There is no need to go over the external internet. They can communicate by using the private IPs or by using some other ways of connections. We will discuss it later, like VPC peering, NAT gateway, VPC endpoints, transit gateway. So there are multiple ways by which it can interact internally. So we will go later. So here VPC are basically the region specific. In one region we can create multiple VPC. So in any one region I will create one VPC. So this is my VPC, and one VPC may expand up to multiple availability zone. So here my VPC is expanding up to 2 availability zone, that is AZ1 and AZ2. Under each availability zone I am going to create 3 subnet. One subnet is public subnet, another is private subnet, and third one is the isolated subnet. Similarly, in AZ2, that is a second availability zone, again I am creating these 3 kinds of subnets. I will give you a small idea about what is public subnet, private subnet, and isolated subnet. So public subnet basically have public IP address, and they are linked with internet gateway through router table, and they can interact with external internet. Okay. Private subnet, they basically have the private IPs. They are not associated with internet. They can't directly interact with the external internet, but if needed we can allow the internet through NAT instances or NAT gateway. So there are ways. And third one is the isolated subnet. So isolated subnet is a class of subnet that basically never have any internet connection, and if forcefully or manually we are going to provide the internet to these kind of subnets, then it will not remain as a isolated, then it will behave like a private or public subnet. So these are the three types of subnets. Now let's go to the code. So if we are coming to code, here it is code. So I have already created the code to save our time. I will give you some information how you can create this code. So suppose if you want to create this CDK project, first creating this, before creating this code, you will have to first create the CDK projects. How will you do this? So first go to create any folder, and then go inside that folder, and in that folder you will have to write the command, but before all these things you will have to install AWS CDK on your local machine. So for that I have already created one video. I will share the link of this video, that video, in our comment section, in our description section. So from there you can take that link and you can go through that video. So here to create this project we can write command like CDK init, and then we can write app, and then here we will write the language, in which language we want to create it, and suppose if it is a Python, then we can write like Python, and then it will create one project skeleton using the Python language. So I have already created this. It will create all these folder structure automatically. Everything it will create. It will even create this requirement.txt. It will have these files, okay, and after this it will create the app.py. This is basically the entry point of our application, and here if you see it has created one stack, okay, and this is the stack where AWS CDK VPC stack, and this stack name basically it will decide based on the folder name where we are creating this application, okay. You can change it, you can change this name, you can change this class name, whatever name you want to do you can give it, okay. And so if you see here it is the entry point, and here it has created one app from cdk.app, and here it is basically passing this one, and here if you see it is checking the environment, and in environment it is basically taking the default account ID, and here it is asking for the default region. So these are the optional thing. If you want to decide that okay in this account and in this specific region it should create the VPC, then yes, you can provide it, otherwise it will create in any other region, okay. So you can provide these things. And if we go inside this code, so here it is basically a class, and here in this class this is basically the constructor, and here our main code is there where we are basically creating the VPC. So here if you see ec2.vpc, and this is the VPC. In this VPC as we know, if we are using any function inside a class, we will have to use the self. We are passing the self, and then what would be the ID of VPC? You can give any unique ID. So I have created the unique ID by using the environment name and VPC name. I am using some constant to provide the VPC name, and similarly VPC name I have given CIDR block. So here you will have to provide the CIDR block. If you might have known what is the CIDR block, so I can make you understand what is the CIDR block. For these I need a notepad. Let it open. So basically CIDR block are you can specify CIDR block like has /32 or suppose 28/24. You can provide any number here, and generally in case of VPC maximum is minimum. As this number increases means more CIDRs, more number of IPs you are providing. So maximum it can go up to /16, and minimum it can go up to /28. And how will you identify that how many IPs will be created if suppose if you are providing this CIDR block? Okay, so how many IPs will be created here? So to identify this, the formula is like 32 minus 32 is equal to 0. And then what will you do? Then you will do 2 to the power 0 is equal to 1. Similarly here, how many number it will be? So 32 minus 28 is equal to 4, and power will be 2 to the power 4 is equal to 16. So similarly for 24, 16, I will request my viewer that you calculate how many number of IPs will be created here, and please mention in the comment section. Let's see who can provide the right answer. And along with this, suppose here this VPC, if we are providing 28 slash 28 CIDR block, then this VPC will have total 16 IP addresses. Total 16 IP addresses. Now, all these 16 IP addresses under these VPC cannot be used. Each subnet under VPC will reserve 5 IP addresses. So suppose in this VPC, if we have created one subnet, then that subnet cannot use all these 16 IPs. That subnet can use only usable IPs. That subnet can use only 16 minus 5 is equal to 11 IPs. 5 IPs will be reserved by AWS for that subnet, and out of these 5 IPs, the first which 5 IPs will be reserved? So out of these 16 IPs, the first 4 IP and the last 1 IP, these 5 IPs will be reserved by AWS for that subnet. So remember it. So this is basically the CIDR block here. And max AZ, so this VPC should expand up to how many AZ in that region, how many availability zone in that region. So here I have given 2, so it will be expand up to 2 availability zone. Create internet gateway. Okay, I have given true, so yeah, it will create the internet gateway. That internet gateway will be associated with my public subnet, so that public subnet will get the internet connection. NAT gateway, right now I'm not creating any NAT gateway, and if not needed, please don't create the NAT gateways because it creates some costs. So this is the detail that I'm giving about the VPC creation. There are few other details you can provide, but minimum these many are needed, so I have provided this many. Now our VPC will have some subnets. So what is basically the subnet? So subnet is basically, you can understand like it's a container where you will add some services like some EC2 instances, some RDS database, some Elasticsearch services you can install, RDS database you can install here. So these are basically the container that keep these services. Okay, so here I have created the 3 subnet. One is the public subnet, another is the private subnet, and third one is the isolated subnet. So for that, this is the configuration that we will have to use. So subnet underscore configuration, and under this array we will have to provide these 3 objects. So ec2.subnet configuration, and then we will have to pass these configurations. So basically it has these 5 configurations and we need to pass this. So name, subnet type, CIDR mask, and map public IP on launch, and IPv6 assign address on creation. I don't need IPv6, I will only work with IPv4, so I'm just using IPv4 address. By default it will assign IPv4 IP addresses. So I've told here that don't assign any IPv6. Name should be unique, so I have created this unique name. And what is the subnet type? So it is basically the public. And CIDR mask, so I am given the CIDR mask is equal to 29. So one thing you should remember that suppose here you have given the CIDR mask. If you see here, you have given the CIDR mask, and this CIDR mask, after calculating, you found that okay, this cybernet mask CIDR mask is having total 32 IPs. So out of these 32 IPs, if you are creating 3 subnets, then the sum of all the IPs used by 3 subnets should be less than or equal to 32. It should not go beyond 32. Okay, so accordingly I have given here the CIDR mask, and based on that it will take the IPs. So 29 means 32 minus 29 is equal to 3. 2 to the power 3 is equal to 8, and out of 8, 5 will be kept by the AWS for this subnet. So this subnet can use only the 3 IP addresses. So this way we can calculate it. And similarly, subnet configuration for second private, I have used the private with egress, and for isolation I have used private isolated. So this is the only thing that you need to do to create your VPC in a particular region in 2 availability zone with 3 subnets, and one subnet is public, another is private, and third one is the isolated subnet. And here I have also provided the CIDR block for whole VPC and CIDR mask for each of the subnets. So here all we understood. Now let's run it. So to run it, first we need to create one virtual interface in this Python project. So for that, what we need to do, first let's see which version of Python is running. Okay, so 3.10. Now let's do Python VNV. Just a second. Just a second. Yeah, so what is the command here? The command is Python -m VNV, and this is my virtual environment name, that is .vnv. Okay, so it will take a few seconds. Let me stop the video for that time. Okay, so here our virtual environment has been created. Let's see in the code base. So here also, if you see, the virtual environment has been created, this VNV folder, but till now it is not having any required libraries, so that we need to install. So for that we need to write the command like pip install, that is -r and requirements.txt. So it will start installing the library that is mentioned here under the requirement.txt. It will take some time, so for that time I am stopping this video. Okay, so it has installed both the libraries from our requirement.txt to this one, to this VNV folder. Now let's enter this into this VNV folder, and let's activate this virtual environment. So how can it be done? It can be done by VNV / scripts / activate. What it is saying, .vnv not available. Why? It is available. .venv. Okay, I need to keep slash .venv slash scripts slash activate. Okay, let me check why it is failing. Okay, for some reason it is not allowing from this CDK, so we can go to our Visual Studio terminal, and from here we can try venv slash scripts slash activate. Okay, so here it has been activated, and if you see now it is running from this .venv folder, and it is getting all the packages from here. And here what commands we need to run. So basically we need to run here 3 commands. Our first command will be like CDK bootstrap, and then it will be CDK synth, and then third will be CDK deploy. So CDK bootstrap, what it will do, it will basically create some of the infrastructure that is required on the AWS side. For example, it will create the S3 bucket there. And why this S3 bucket is needed? Because when you will trigger the CDK deploy, then it will create the CloudFormation template, and that file will be saved in that S3 bucket. And it will also create a few policies and few roles that is required for this deployment through this CDK process. And once it is done, then we can run the CDK synth. CDK synth is basically for the local testing. It will run your code in your local environment, and it will create CloudFormation template.json file. You can go through it. If it has been created successfully, then it's well and good, it is working, and then you can trigger the CDK deploy. If CDK synth is giving some error, then you should fix that error, and then you should trigger the CDK deploy. Okay, so let's first run this, that is CDK bootstrap, and here I've run it. Let's expand it a bit. So it is taking some time, and before this I'm thinking to show you here. If you see here right now, I'm in my AWS console, and here if you see one VPC is already created, that is the default VPC. Whenever you will create your AWS account, you will get by default one VPC, that is the default VPC. This 6 subnets by default you will get, one routable by default you will get. So beside this, I am creating the other VPCs and other subnets through my code. So once I will trigger the deploy, then that will be visible here. And if you see, if I will go to my subnet bucket and through to S3 bucket, I don't have any S3 bucket. So if my command, that is CDK bootstrap, will run successfully, then it will create one bucket here. So all those things I will show once this command will be successfully run. And here it has given some error. I'm fixing it. I will show you why this error has happened. Okay, so for that some minute I'm pausing. So from this error, it is clearly visible that I had installed these packages from requirement.txt. Globally I had installed. That is wrong. I should have installed in my this .venv folder. So first I should have activated this. So I have already activated it, and now I should have installed it here. So like pip install -r requirements.txt. So now it will install these libraries under .venv folder. It will take some time. I'm stopping the video for that. So if you see, it is installing here those libraries. It is installing all those libraries here. and once this installation will be completed, then we will move ahead. By that time I am stopping this video. Okay, so if we see here, the installation is completed. Now let's clean it, and then we will run CDK bootstrap. So again it will take some time. By that time I am stopping this video. Okay, so this command has run and it is giving some error. So it is giving error that VPCs must be between 16 and 29, and the minimum subnet size is 28, and I have provided one of the subnet size as 29, so that is wrong. Minimum subnet size I can give as 28. So here I think these two have given 29, so that is wrong. I should not give it as a 29. So let me increase it to 28 minimum, and then I will try. Okay, Control S, and then come here, CLS, and then the command. Let's run this. I'm stopping this video because it is going to take some time. Okay, I'm coming here, starting. Okay friends, so it is running now, and it is also showing the message like bootstrapping the environment, and it is further creating a few infrastructure there on my AWS side, and it will give you the information what are all the things it is creating here, and you can see all the details, what are all the things it is doing here. Okay, and it will keep updating here. So there are the 7 tasks that it is about to do, and it is saying how much is done, how much update is failed, all these things it is giving. And let's wait for its completion. So by that time I am pausing this video. So friends, now this has CDK bootstrap has run successfully and completely, and it has successfully created triggered all the 12 tasks, and all are completed here. A few more issues I had found. First was that CIDR block issue, so that I fixed. I increases the CIDR mask size, and then that got fixed. And few more issues I got here, like it was trying to get the ECR creation policies information, and it was not getting that, and basically we are not doing anything related with the images container or ECR. So I stopped it. How I stopped it, so that I will show you. I went to this one, cdk.json file, and here these container slash ACS service, it was true, I made it false. And when again I triggered this CDK bootstrap, then it ran successfully. Now I will run my second command, that is the CDK synth, and let's see how it is running locally. Is it creating the CloudFormation template.json file locally or not? Let's see that. So I am running it, and again but before this, let's see whether it has created here any S3 bucket or not. I think it should create. Let's see. So I'm refreshing it. It will take 1 minute, 1 or 2 seconds. Let's see. So yeah, it has not created right now, but nothing to worry. Let's run our next command, that is CDK synth. CDK synth. So again it will take some time, and I'm pausing my video. So friends, here I just refreshed again my screen, and it has created this one, that is the CDK HNB bucket under Northern Virginia, that is the US East 1 region. And if you see, its date is today's date, and just now, even time is also just now time. So it has created, it just took a few seconds to replicate here, and by that time our CloudFormation template has also completed successfully, and it has created one folder that is CDK out. And if we come here, then we will our file here. So this is basically the file, that is CDK AWS CDK VPC stack.assets.json. So this file name will be according to the name of the stack. So if you see here, the name of the stack is this one. So same stack name it has used here, and this stack name it has taken from our class name. So you can change it. If you are changing the class name and you are changing here the stack name, then accordingly the file will be created. But this is for local testing. We are not going to move manually these files to the S3 folder. We are not going to do this. This CDK synth is basically to test it locally, that in our local environment is it capable of creating this CloudFormation template.json file successfully or not. If it is giving that some error, then we need to fix it. But here it has created it successfully, and if you see it here, it has shown these things, that this is the stack name, and this is the display name. So all these things, all this information it has given here. Okay, and if we see here, this is the template.json file, that CDK CloudFormation template.json, and here if you see, it has given the complete information, and here it would have given everything whatever we want. And this is a quite big file, and it will create everything here. So if you see here, it has created the public subnet, and these are the things that it has created. Few name will not come here once it will be created in deployment time, then it will be shown there. Okay, and when so now our last command is this CDK deploy. When we will trigger the CDK deploy, then it will again first create the required CloudFormation template.json file, and it will put that JSON file in our S3 bucket, the bucket that I just shown you here. In this bucket it will put, right now it should not have any file, any object. So this is completely blank bucket is there. So if we will run CDK deploy, it will create the CloudFormation template.json, and that JSON file will come here, and from here it will read this JSON file, and then it will create the VPCs and subnets. So all these things it will do when we will trigger the CloudFormation when we will trigger CDK deploy. Here if you see, it's still having it should have still one VPC only and 6 subnet only, because we have not deployed till now anything. So let's verify this. So yeah, it is still having one VPC, that is the default VPC, and 6 subnet, that is the default. Now let's run our CDK deploy command, CDK deploy, and it will take some time. So by that time I am pausing my video, and once it will be successfully completed, I will show you. So if you see here, it is publishing all these templates, and it is saying here that all these tasks needs to be completed, and it will ask you these questions that do you want to deploy these changes. Here it has given you all the changes that it is going to deploy, and it will ask you that if you want to deploy all these things, and if you will say yes, then it will move ahead, otherwise it will not deploy anything. So this is the last point where you can say no and it will abort everything, it will not deploy anything. If here you are saying yes, it will start deploying. So here I am saying yes, and then it will start deploying. If you see here, it is saying that AWS CDK VPC stack it is deploying, it is creating the CloudFormation chain set. So all these things it is doing here. Again, it will take some time to complete it, and once it is done, then I will show you. So here you can see it is creating all these things. So all these information it is giving, that what are all in progress, what are all completed, it is giving here, and we can keep track here that okay, what are all completed successfully. So yes, it will take some time. Yes, so here if you see, it has completed the deployment process, and it is also saying that this deployment has taken the 76.92 second, that is almost 77 second, and this is our CloudFormation file locations. And now if you see here, it has given the detailed information, what are all the things it has created and what are all the things it has deployed. Now let's go to here in our AWS console and let's see. So these are all the previous information before deployment. Now I am refreshing it, and let's see how much VPC, how much subnets are right now after deployment. It may take some time to replicate here, but yes, it has replicated. Now we are able to see that it has, now we are getting the 2 VPCs, 12 subnets, router tables, few more router tables are there, 2 internet gateway, one was the default internet gateway and one internet gateway is created by this one. So it has created. And if we see here, if we refresh it, this bucket should have that CloudFormation template.json file. It should have. Let's see. So yes, it is having the JSON file. It is having the JSON file and the zip file. Now let's see those VPCs. If let's go to the VPCs here. So if we see, this is our current VPC. This VPC has been created. We can go, this is our VPC ID. We can go to this VPC, and here we can see all the informations. It is showing that we are having those 6 subnets, 7 route tables. Each subnet is having their own route table, and then these are the CIDRs. Okay. And if we come to the subnets, let's go to the subnets here. So these are all the subnets. This is the private subnet that we have created. If you see, all the informations are there, and subnets we are having. So this way it has created the subnet, it has created the VPCs, it has created the route tables, and once we are done with this, then we should delete this infrastructure, otherwise it will create some cost and we will have to pay those costs. So to delete this, we can run the command that CDK delete, and after successful completion of this command, we can once go to our AWS console and we can verify that whether all the services, all the policies, all the cloud, all the logs, each and everything has been deleted or not. If something is not deleted, we can delete it manually, otherwise there are chances that we can get some billing, some cost in the billing, and we will have to pay. So to avoid that, first we should trigger this command, and once this command is successfully triggered, then we should go to our AWS console and manually see that if anything is yet to be deleted, we should delete that manually. So this is all that I had today to discuss with you. Hope this will help you to understand more these VPCs and how can we create these VPCs, subnets, CIDRs by using this infrastructure as a code. So if this video is helpful, then please like this video, share it, subscribe to my channel. So that's all for today. Thank you.